Hi, welcome to Delaview Management's construction blog. My name is Dave Smith, and I'm the president and founder of Delaview Management, a consulting and estimating firm servicing the building supply and lumberyard industry. If you've watched our introductory post, you understand this series of videos is designed to give you the basic information needed to be able to talk with construction professionals, such as builders, project managers, job site supervisors, framers, subcontractors of various trades, estimators, etc. It's targeted towards entry-level lumber and building material salespeople, project managers, estimators, and the like. Each segment of the series will cover a specific phase of typical residential, light commercial, non-high-rise construction. We'll cover the most common types of systems used and the materials and methods used to construct them. As the forum progresses, we'll cover more complex systems and assemblies. All of our sessions can be found on YouTube. I encourage everyone to comment with any questions or additional information. Thank you. In this segment, we'll cover the three most common types of foundation systems: slab on grade, crawl space basement, and piling. All foundation systems have one thing in common. Their primary purpose is to transfer all the loads of the structure to the ground below. In all cases, the loads of the structure must be distributed to stable surfaces below the grade that can support the weight. Usually the weight is spread out through footings made of concrete that are wide and deep enough to transfer the weight from above and stabilize it. In most parts of the country, there are several factors that determine how this will be accomplished, such as the type of soil, the depth of the water table, the climate, and typical lowest temperatures in the area, as well as the type of structure being built. Foundations in colder climates require footings or piers that must be deep enough to be lower than the frost line. The frost line refers to the depth at which the moisture present in the soil is expected to freeze. If footings do not bear below the frost line in colder climates, the ground will heave and create a potential for cracking and shifting. The simplest type of foundation is slab on grade. Just as the name implies, the first floor of the structure is made from a concrete slab that sits at or above grade. There are footings around the entire perimeter of the structure, wide and deep enough to support all the load-bearing outside walls, as well as footings under the areas of the slab that will have bearing walls or point loads from columns or posts above. The framing above is typically fastened to the foundation around the perimeter with anchor bolts or straps that are embedded into the concrete when poured. The advantages of this type of foundation is that it is simple, relatively inexpensive, and works well where there are higher water tables to deal with. The disadvantages are that there is no way to get additional living space from the foundation as with other systems. All utilities must be located exactly where needed below ground prior to pouring the concrete, or must come in through penetrations in the walls or roof above. In areas with high ground moisture, provisions must be made to eliminate hydrostatic moisture from wicking through the slab. Flooring options on concrete surfaces are limited and require special adhesives or pressure-treated wood sleepers with subfloor on top, which can negate any savings. Crawl spaces and basements are very similar to each other in concept. Typically, a footing is poured below the frost line of the necessary width and depth to support the loads transferred from above. Once the footing is cured, concrete or masonry walls are constructed on top of the footing to a predetermined height of the first floor framing. There are many different types of material that can be used to construct these walls. Concrete block, commonly referred to as CMU, which stands for Concrete Masonry Unit, can be installed using mortar, which is a sand and Portland cement mixture, to adhere the block to the footings as well as each other and stacked. This system is relatively inexpensive and does not require expensive formwork or highly trained workers to install. In areas with stable soil and acceptable groundwater level, it is usually sufficiently strong and stable enough to provide a solid foundation, but because it's made up of individual blocks and mortar, it is not as strong or water resistant as poured concrete walls. Concrete walls can be formed and poured on footings once they have cured. This is a very strong system and is highly resistant to water penetration if sealed properly. In both CMU and poured concrete wall systems, steel rods called rebar can be used within the core of the wall to provide additional lateral support, making these systems very strong and versatile. Concrete walls can also be precast at a factory and shipped to the project and installed. These systems can include built-in ribs and insulation, making it easier to finish a basement later. The installation can often be done in one day as the concrete does not need to be poured and set. There are also insulated concrete form systems and insulated concrete block systems available. These are much more energy efficient and can be installed quickly, but are typically more expensive. The main difference between a crawl space and a basement foundation is obviously the height of the walls. In a basement, the footings are deep enough and the walls are high enough to provide usable living space that can be finished or not finished below the first floor of the structure. Usually, the interior loads are transferred from above to beams that bear on steel or wood columns resting on footings below. A slab of sufficient thickness is poured to create usable space. The advantage of a basement is obviously that it provides another level to the structure, either for living space or at least to house the mechanical systems and provide additional storage. Basements do take up some room on the first floor since a stairwell is needed for access. A crawl space is very similar to a basement, but the walls are shorter. The interior loads are typically placed on concrete or block piers or walls, and the spacing can be much less, thus not requiring larger, more expensive beams to carry the loads from above. In both systems, the first floor system is typically placed on a pressure-treated sill plate that is bolted or strapped to the foundation wall. Beams to support the floor framing are either placed on the sill plate if they are to be flush with the joists, or dropped into notched pockets and/or piers in the foundation walls if they are to be dropped below the joists where needed. Crawl spaces do not provide additional living space due to the low headroom, but do provide additional storage and a place for water, sewer, gas, and mechanical systems to enter and exit the structure. Access can be achieved either through an access door or stairwell on the first floor or an exterior access panel or door. The last type of foundation system we're going to discuss in this segment is a piling foundation. Pilings are columns that are driven into the ground until they reach a predetermined depth to bear on suitable soil or bedrock. These systems are typically only used in areas that have unstable soil, like sand or very high groundwater levels, such as ocean or lakefront properties. Pilings can be used in several different ways. They can be used to support typical concrete or CMU basement or crawl space foundations below in areas where these systems would otherwise fail. Pilings can also be driven into the ground and left exposed high enough to support structures above, providing a usable area at ground level that can be used to prevent floodwaters from entering the structure in high-frequency flood zones or for storage, parking, or even living space, depending on the type of structure and where it is located. In this type of system, a series of beams are usually notched into and fastened to the piling to support the structure above. It is basically a post and beam system. While this certainly does not by any means cover all types of foundations or materials and products that can be used, it provides the basic groundwork to build on, no pun intended, for upcoming sessions. Thanks for watching, and feel free to comment.